So I also think this is an interesting example that he uses here for those of us who lived through this right here. You guys did not, but Netflix was founded in 1997, and they were a mail-order DVD subscription service. I remember this well. You filled out a form, you mailed it off, they sent you DVDs in the mail, you watched them, then you put them back in the little envelope they came with, and you mailed them back to where they came from. That was Netflix in my day. In 2007, they transitioned to a streaming service. So that was probably about the beginning of your life here, somewhere around there. Maybe a little bit before the beginning. With this streaming service, they had 7.32 million subscribers. By 2015, they had grown to 70.83 million subscribers. And the number of Netflix subscribers can be modeled by the function N equals A times B to the T, where N of T is the number of subscribers in millions of for year T, and T is the number of years since the initial launch of Netflix streaming service in 2007. We are supposed to use that data to write two equations that can be used to find values of A and B in the expression. So, in this case, they may give you several different types of equations right here for that N of T equals A times B to the T. It could be a log, it could be an exponential, it could be something else. But logs and exponentials are the main ones that they use here. So, what you need to do is think of the points that you would have. T equals 0 is 2007. They have 7.32 million subscribers. There is not a need to change that to 7,320,000. Just put the word million at the end of your answer. That way you don't have to convert it. It will just be easier. So you have the point 0, 7.32. And then we also have the point 8, 70.83. And in these cases, your x-coordinate is your t, your y-coordinate is your n of t. So, again, they may give you a different equation. They may give you something that has like a plus c on the end. They might give you, ones that are not the programmed regressions that are in the Desmos calculator. It doesn't matter. You're going to do it the same way no matter what. In fact, if this part confuses you, particularly if it's a different type of equation, here's what you can do. I'm going to write down this. If you got a pencil, follow me. If you don't, you might not want to. You're plugging in the point, right? So you're erasing n of t, and you're putting the y-coordinate, so that is 7.32. And you are erasing the t-coordinate, which is like your x-coordinate, and you're putting a 0 right there. There's your first equation. Right? You're plugging in the t, you're plugging in the n of t. The A, the B, they stay. If there's other letters like a plus C or something, it stays. Don't replace them. Okay? And he's got a note right here. Time is almost always the input. Not necessarily always, but most of the time, your year or your months or whatever is usually your input. And then you're going to do the same thing for the other point. So, again, if you need to, write it out, and then erase n of t, replace it with 70.83. Erase your t, put an 8 right there. Okay, so these are your two equations. The equations are what they're asking you for. This is how it's going to be worded. Don't do anything else right here. Stop. This is what they're looking for. Okay? Any solving happens in Part B. This one can be solved by hand. He has a note right here. It says sometimes you can use regression to solve for A and B. Now, that is from last year. We can pretty much always use regression to solve for A and B because in Desmos, you can do regressions that are different than the programmed regressions. On the TI-84, it will only do certain programmed regressions. This one is a programmed regression, so you can use it if you want. It might be safest to not, so that if you get one that is not a programmed regression, you know what to do. So whenever you put this into Desmos, you are just going to do a table. You are going to enter 0. Split screen this so I can see what I'm doing here. We're going to enter 0, 7.32. We are going to enter 8, 70.83. And then you can use the programmed regression for this, or it might be safest whenever we've got n of t equals a times b to the t power. Your t was your x1. So you're going to have x1 right here. And your y was your n of t. So it's going to be y1 squiggle. Okay. Now this is not like, you don't have to write that down. But if you need to, do. So like that n of t is what we put in the y1 column. The t is what we put in the x1 column. So we would type in y1 squiggle a times b to the x1, and it will give us the regression. Now for this one, you could just go change it to exponential regression, but if it has, like, if they put something like a plus c out here on the end, the exponential regression will be wrong if you have a plus c. Whereas if you rely on the typing it in, you'll still get it right. Okay, so it might not hurt to kind of have this be your default of what you are doing here. Whenever we do this, the other good thing about it is this gives you the equation. This way gives you A equals and B equals, which is what they're really looking for here. So you just write down A equals 7.32 and B equals 1.32805. You only have to be correct to 3 decimal places. However, for what you're doing for this problem, the best thing is to use this graph that is solved. Don't round that off and then use it for the answers, right? I'd give the whole, especially on exponentials, you'll be way off. Right, they won't catch off for that, as long as your first 3 are correct. Yeah.
So what happens if you, like, you end up rounding to the third, and then you use that as your
Like if you use 1.328, I'm not certain on that either because I have not graded this exam, whether they forgive you and grade with you on that, because you won't lose a point for rounding here, but you are going to be off on your answers at the end. I just wouldn't do it because I feel like it's risky. I'm not sure what they do with that for those. Okay, questions there? All right, now we have had the Part B section of this several times, but it's been a long time. It was at the beginning that we kept doing this because it didn't have this. This one will have nothing to do with trig. It won't be a trig problem. I don't think anyway. I have not seen one that's trig anyway. So this is all average rate of change, which is treating it like it's linear, which confuses students, but everything it's asking about in Part B is linear. Okay, so use the given data to find average rate of change in the number of Netflix subscribers in millions of people per year from t equals 8 to t equals 0 to t equals 8. Express your answer as a decimal approximation. Show the computations that lead to your answers. This is slope between the endpoints. So those 2 points that you wrote down for the beginning, that's what you're doing. You're just doing slope between the endpoints. Make sure you know it's changing y over changing x. Every time when I grade these, somebody had that flipped, right? So make sure you know that. So in this particular case, you're going to have 70.83 minus 7.32 over 8 minus 0. This is calculator active. You don't have to show any work on that. You have to write this down because it shows the work. It says show the work that leads to your answer. So you got to do 70.83 minus 7.32 over 8. You're going to get 7.93875. So 7.93875. Again, you could round here, but you're probably going to have to use it later, so I would just keep it. It's not that many decimals to worry about. It is probably a good idea because they're going to ask you to interpret the meaning of your answer in part 2. So I don't think you have to have units in part 1. You are going to have units in part 2. So it is not a bad idea to recognize that this top part is million subscribers. Right? And this bottom part is years. Right? So your units right here are 7.93875 million subscribers per year. So for part 2, they're going to ask they likely might ask you to interpret here. And Mr. Passwater has your foolproof fill-in-the-blank answer that's going to work right here. On average, the blank increases or decreases by blank units from t equals blank to t equals blank. Okay? So in this case, we would say on average. What are we talking about here? What goes in that first blank? The what? We want to be specific to this situation. What are we looking at changing? The subscribers. So the number of subscribers increases in this case. But if it was decreasing, we would put that. Increases by our answer from up here, 7.93875 million subscribers per year. From t equals 0 to t equals 8 years. Or it might be better on this one to say 2007 to 2015. That might be better. It would definitely be accepted if you did that. But I think you'd be okay if you just went with this like formula right here. If you do on the interval, if you do that, say on the interval 0 to 8, make sure you put years with it. So, because this part needs to be very much tailored to the situation that you're talking about. So you don't want to go like too general mathematical terms because what you're saying might be true. Like if we had said rate of change, like what we were saying would have been true, but it wouldn't interpret it in the context of the problem. So you need to be, units are key, and describing the situation, like what is changing, is key for that. Okay, if you do this, you will get it right. It should be something increasing or decreasing per year, per hour, per day. It's going to be time that is whatever's on the bottom most of the time. Okay. Sometimes they don't ask you to interpret. Sometimes they ask you to predict. Okay. So this is an alternate part too. You will not see the interpret and the predict on the same problem. So this is an alternate part too. So whenever you see like the problems that you guys have tonight, some of them might ask you to interpret, some of them may not. They may ask you to predict. So it says use the average rate of change found in I to estimate the number of Netflix subscribers at time t equals 6 years. Show the computations that lead to your answer. So he has y sub 0 plus a rock, which is your average rate of change, which is what you found in part 1, times t minus t sub 0. Okay, so I think that what he's gotten written down here is more helpful. Your final answer to this is going to be your given amount plus your average rate of change times the time that is lapsed. In this particular case, they are asking us for t equals 6. We have the number of subscribers at t equals 0 and t equals 8. Which one should we probably pick? Let's pick 0 because 8's too far, and then we'll have to use like negative time, and it could be done, but it'll be confusing. Yes? In this particular case, because they give you t equals 0, yes, you can write a line for it. A lot of times it might not start at 0, so like you won't have the y-intercept. But what we're doing is like average rate of change is how much it goes up each year, right? So if we want to know t equals 6, well, at 0, we had 7.32 million subscribers. Plus, our average rate of change was 7.93875 million subscribers per year. And it's going to go up that much each year for 6 years, right? So that'll be times 6 right there. And then you want to write that down, show what you're doing right there. And like I said, I would not round anything because you are using it here. So I would say 54.952 million subscribers. At t equals 6 years. Now sometimes it might not be like the number 6. Like they might have given you how many subscribers there were at year 2. So then you'd have to do 6 minus 2. Only 4 years have gone by. So you'd multiply by 4 instead of that 6 right there. If our initial amount was different. Okay. 3 says consider the average rates of change from n from t equals 8 to t equals p years, where p is greater than 8. Are these average rates of change less than or greater than the average rate of change from t equals 0 to t equals 8? So, in this case, we are talking about n right here, this n, that is your exponential function that you were given earlier, right? They told us n of t equals a times b to the t power. So if I look at like what I've got graphed here, let me go up here. If I were to draw like a line, I could do the line if I want. It's going to be y equals 7.93875 x plus 7.32. There's the line through those points right there, and that is just y equals mx plus b. I got a slope and the y-intercept. So what it's asking me is like out here, is my average rate of change less than or greater than the average rate of change from 0 to 8. So is my graph steeper or less steep than that average rate of change? The actual black graph, the N of t graph. It is more steep, right? So that average rate of change is going to be greater. Okay? It would not hurt you here. It says you're using the shape and behavior of the function. There's a lot of different ways that you could explain this. It does not hurt here to show like a little sketch where you call this N of t, put like H right here. Like this. And call that the linear model. And so you could say something like using the linear model, or let's use using the average rate of change. The number of subscribers increases at a constant rate. But N of t, what can we say about the rate of change of N of t? We could use the word proportional. I would probably go with a different phrase. Is N of t, is that black graph, is it increasing at a constant rate? What could we say about how that rate is increasing? The N of t increases. You could say exponentially, and you might be okay. What I would go for is increases at an increasing rate. Right, so it's increasing just tells me it's going up, right? At an increasing rate is telling me that it's like concave up. It's getting like steeper and steeper and steeper, right? So since this is increasing at an increasing rate, we can make the conclusion, and I would just restate what they're asking you in the problem. It says, are the average rates of change less than or greater than the average rate of change from 0 to 8? So we could say, therefore, the average rate of change from t equals 8 to t equals p years is greater than the average rate of change from t equals 0 to t equals 8. So I'm kind of just like restating what the question was asked, like this part, the average rates of change of n from, I'm saying this, are these average rates of change less than or greater than the average rate of change from 0 to 8 years? Found in part I. So you're kind of just saying this stuff that they said, I'm restating that, is greater than this other stuff that they said. Have to write in pen. I don't, I will double check, but I'm pretty sure the answer is no. And on the math ones, you can use pencil. I think you can use pen if you prefer. The one I don't know about is erasable pen. I think I'd go pencil. I'm afraid erasable pen, like, in the heat of moving from, you know, it's because, like, actually, I think those actually get mailed to a place. Like, I don't think we scan them here. I think they get mailed to a place, so I would probably not use erasable pen. I would either use pen or pencil. I don't know. Maybe, though. I would be, as much as I love a good erasable pen, I probably wouldn't use it on this.
I know that he will make an erase because I've used an erasable highlighter with script and left it in the car.
Yeah, yeah. So, let's not use anything erasable unless it's pencil. And I believe Coach Foster will probably have pencils. I will make sure he has pencils for you because he's not done it. You know, he has not done AP testing here before. He was in charge of it at North Surrey, but last year Miss Phelps was still here, so she did it. So I'll make sure he's got pencils also. If you guys, I would use pencil if it were me. Make sure you write so they can read. They give you lots of space. Write so they can read. I'm going to tell you, when I was grading AP exams, I was horrified at how terrible some of those kids' writing was. It was awful. And this is not scratch work for your homework. It needs to be neat and easy to follow, because if they can't follow it when you're grading it, or if they can't read the words that are on there, they try to give you benefit of the doubt, but sometimes it's just not, you can't get anything from it if it's really bad. So try to do your work in an organized manner. If you have to go to, like, if you're not either working across or down, draw an arrow so they can follow. On some of y'all's FRQs on that last test, it was a mess. It's not time for scratch work. It needs to be neat, 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 right? So some of it, like, you have stuff all over the place with no equal signs, with no arrows. I can't follow where you're going on that, so neat on this stuff. Then we have a part C. For which t-value from t equals 6 to t equals 19 years should we have more confidence in when using the model N? Give a reason for your answer in the context of the problem. So, part C, it says here, is going to always ask us about some sort of restrictions for our model. This part also may ask how we should limit our domain or our range for our model. Okay. Do you guys think that Netflix subscriptions are going to continue to do this forever? I mean, like, you know, I wonder what it would be like if we added we're in 2025. Minus 20, 2007. So, like, we got 100 and, or one, it'll be 1 billion, 1.2 billion subscribers. I wonder what it actually has. Number of net. $301.6 million. So, like, it already doesn't work, right? It's continued to increase, but it already is not applicable for our situation, right? Because this can't happen forever. There's a limited number of people on the planet that can be Netflix subscribers, right? in this particular case, are we going to have more confidence when we plug in 6 to our equation or when we plug in 19 for our equation? 6. We have more confidence when t equals 6 years, because that value falls within our given data points. And I would add something like this trend may not continue out to t equals 19, which it might be helpful to say that that is 2026 there, just to give yourself an idea of like, well, this may not still apply, right? For that. They might ask you to restrict domain on this. So if you're restricting domain, you would need to say, like, maybe I want to go 0 to, if you go 0 to 8, you'd have a good argument for that, right? Because you know the points there. You could go maybe 0, you could say 0 to 10, 0 to 12. I mean, as long as you explain it, it would make sense. I wouldn't go past the year 2020 because after that, subscriptions may not continue to increase. You got to have some sort of reason like that. If that's you to restrict the range, what would be something reasonable to restrict the range to? The range are your Y values. That's your number of subscribers. 8 billion. Okay, 8 billion. Why? Can't go over the population, right? You could go lower than that. You could say like maybe 4 billion, because you figure that even if everybody in the whole world subscribes, they're still going to have like one other person living in their household, and they're not going to both get their own Netflix subscriptions, So, like, as long as you have a good reason behind it, you would be okay there. So it's going to ask you to do something like that. Okay, questions? All right, it took us too long to